everyone, and today I am presenting a summary of the paper titled A Neural Network Approach to Handwritten Digit Recognition. This research explores how a neural network model can be trained to recognize handwritten digits accurately. The authors used a simple neural network approach to achieve impressive results, which I'll walk you through in this presentation. Handwritten digit recognition is crucial in fields like finance and postal services where automation helps process checks or addresses. However, variations in individual handwriting make it challenging. As we can see in these figures, 5, 0, 4, these are all handwritten digits and they vary in shapes a lot. In this study, the authors implemented an artificial neural network specifically designed to recognize digits with high accuracy, addressing these challenges through a well-trained neural network model. Now, the dataset which they use is the MNIST dataset. This dataset is widely used for training and testing in image recognition. It contains 70,000 images of digits from 0 to 9. Each image is 28 into 28 pixels in grayscale. Now training set contains 28,000 images and for testing there are 14,000 images, ensuring that their model learned from a diverse set of examples. So this is how the data will look like. All the images in this PPT are taken from the paper. The link for the paper is you can find in the description below. The neural network architecture in this study is straightforward yet very effective. It includes three main layers. The first is the input layer, which contains 784 neurons, one per pixel, so 28 into 28, which gives us 784 neurons. Then there is a hidden layer with 100 neurons corresponding to as per the effectiveness in optimizing the accuracy. And then there is an output layer which has 10 neurons, one for each digit, that is 0 to 9. As you can see in the figure, the input neuron 28 into 28 pixels, which gives us 784 pixels. Then hidden layer, these are the number of neurons in this layer are determined by the author and they are chosen as to have the maximum effectiveness. Then there is an output layer which is based on how the output is. So in this case we have 0 to 9 digits, so we have 10 different classes, so 10 neurons. Now the training process involves forward propagation to calculate predictions like in this direction, and then the backward propagation to adjust weights, gradually improving the model's accuracy. Now we'll see how the training looks like. Now the training, the author divided their dataset to avoid overfitting. So the training process involves 90% of the data was used for training and 5% for validation and 5% for testing. Now those who are familiar with the basics of neural networks, they understand that like this training, validation and testing is very important for calculating the performance matrices. The confusion matrix is discussed in the next slide. The network minimized cross entropy error to improve accuracy, a method often used to measure prediction error in classification tasks. During training, the model adjusted its weights to reduce this error over multiple epochs, achieving optimal performance after 107 epochs. So here you can see the graph of 113 epochs where the plot for cross entropy error is plotted. For red line is for the test, green is for the validation set and blue line is for the training set. Let's see how the testing is done. After training, the model was tested on a separate set of 14,000 images and achieved an accuracy of 99.6%. The confusion matrix used by the authors highlights correct classification in green and misclassifications in red. This high accuracy demonstrates the effectiveness of the ANN model, which outperformed similar models such as SVM and CNN SVM hybrids. So these Comparison with the similar models is done in the next slide. As you can see, in comparison to other methods, this neural network approach stood out. For example, in previous studies using SVM with RHOG, features achieved 95.64% accuracy, while CNN SVM hybrid it achieved only 94.4% accuracy. Here the authors ANN trained directly on pixel data without complex feature extraction achieved a high accuracy of 99.6, demonstrating the power of this simple yet efficient approach. Now, the comparison with other methods is also explained in this table, which is taken from the paper, and the references are given in the first column. Now let's see at the challenges which can be faced during implementing this kind of simple ANN algorithm. The first challenge is variability in handwriting makes perfect accuracy difficult. So while this study achieved high accuracy, the authors noted these challenges. The main difficulty is the variation in handwriting, which can lead to misclassification, especially for digits with similar shapes like 1, as you can see 1, 7, they have almost similar shape. 4, 9, here also you can easily uh, miscalculate it and the accuracy can go down. So moving forward, the authors plan to use more datasets and optimize the ANN parameters. They are also interested in exploring hybrid methods and ensemble classifiers for improved results. Thank you.